All right, let's dive in. Today, we're going to unpack one of the coolest and most powerful stories in all of chemistry, the Aldol reaction. Now, this isn't just about mixing stuff together. This is the real story of how chemists actually create things, building the world around us one tiny molecule at a time. So let's start with a really big question. How do you actually build something complex, say a new drug or a new material, from simple, basic starting blocks? In chemistry, that is the ultimate act of creation. And it really all comes down to knowing the right moves. And one of the most famous moves in the playbook is the Aldol reaction. The big idea here is actually pretty simple. As you can see, we're taking two identical, simple molecules, and through some amazing chemical choreography, we're going to link them up to form one bigger, more interesting molecule. That's the journey we're about to take. Now, before we get into the how, let's talk about the why. Why is this such a big deal? Well, forming a new bond between two carbon atoms is basically the holy grail of organic chemistry. Seriously, it's like having a master key that lets you build the backbone of pretty much any organic thing you can dream up, from life-saving drugs to super advanced plastics. So how do we pull this off? Well, our story has 3 acts, and Act 1 is all about getting ready. See, you can't just smash two molecules together and hope for the best. That's not how it works. We need to prep one of them. We need to turn it into an attacker. And this is where the magic starts. We bring in a catalyst. In this case, it's a hydroxide ion. Think of it like a coach. Its whole job is to come in and pluck a very specific hydrogen atom, a proton, right off of our acetaldehyde molecule. This one little move completely changes the molecule's personality and gets it ready for action. And this new, amped-up personality, it's got a name, the enolate ion. By yanking off that proton, we've created something called a nucleophile. For our story today, just think of the nucleophile as our hero. It's now loaded with electrons, it's got a negative charge, and it is actively looking for a positive target to connect with. It's officially primed and ready to go. Which brings us to Act 2. Our hero is ready, the stage is set, and it's time for the climax of our reaction. This is the moment where that new bond is actually formed. And boom! Here's the attack. Our enolate hero, with all that negative energy, is irresistibly drawn to a second, unsuspecting acetaldehyde molecule. It specifically zones in on the carbonic carbon. That's the one double bonded to the oxygen, because it has a slight positive charge. You know what they say, opposites attract. And in chemistry, that attraction is what creates brand new things. Okay, let's hit pause for just a second to make sure we've got our players straight. On the left, we have the nucleophile. That's our electron-rich enolate ion, the attacker. And on the right, we have the electrophile. That's the second acetaldehyde molecule, which is electron-poor and has the perfect positive target for our hero to attack. And contact! That is the moment. The electrons from the enolate rush forward and bam! They form that all-important new bond between two carbon atoms. In this one instant, something totally new has been created from two separate pieces. It really is the pinnacle of the entire story. But hold on, the story isn't quite over. After that big dramatic moment, our newly formed molecule is in a really reactive, kind of twitchy, unstable state. It needs one final touch to become the finished product. So welcome to Act 3, the resolution. As you can see here, our brand new molecule, this aldoxide intermediate, needs to neutralize its negative charge to chill out. And to do that, it simply reaches out and grabs a proton from a nearby water molecule. That one simple move stabilizes the entire structure, and just like that, we have our final, completed product. And here is the most elegant part of the whole thing. Remember that hydroxide base from way back in step 1, the one that kicked this whole process off? Well, in this final step, when our intermediate grabs that proton from water, that exact same hydroxide ion is spit right back out, completely unharmed. It's now free to go find another molecule and start the whole dance all over again. That, right there, is the magic of a catalyst.
So we've followed the entire molecular journey from start to finish. Let's zoom out one last time and just recap why this 3-act chemical story is so incredibly important.
It really just boils down to these 3 steps. First, you activate a molecule to turn it into an attacker. Second, that attacker goes out and forges the new carbon-carbon bond. And third, you stabilize the whole thing to get your final product. Activate, attack, stabilize. It's a simple, powerful, and repeatable way to build bigger and better molecules. And, mastering a fundamental reaction like this is so much more than just an exercise for a chemistry class. It's the absolute foundation of chemical innovation. This is how we get our minds thinking creatively, and it's how we build the tools to literally shape our